Okay, this is about water draining from a funnel. So the question is, water is draining from the bottom of cone-shaped funnel at the rate of 0.03 feet cube per second. The height of the funnel is 2 feet and the radius at the top of the funnel is 1 feet. At what rate is the height of the water in the funnel changing when the height of the water is half feet? Okay. The first it is that is water is draining from a funnel which height is 2 feet and the radius of uh, one feet. So there is a funnel. First I have to make a little funnel like that. Okay. Now the next is the funnel, the height of funnel is 2 feet. So the height will be from this point to this point, it will be 2 feet. Okay. And this the radius is what? Radius is 1 feet. So I will make the radius that is, make a center 9. Okay. So from this point to this point, there will be a radius of 1 feet. Okay. So this is the first thing, that there's a funnel that is cone-shaped funnel having height of 2 feet and the radius of 1 feet. Now the next thing is the height of the water and the radius of water are changing over time. Let us see that the rate, this is the water draining from, that it is draining from this side, that is water is flowing from this point. So the height decreases. Let us say that the new height is this one. Okay, so first height will be this point. Now the next height after draining some liquid, the height of the liquid will be this one. So my new height will be from this point to this point, which is my h, and this is the new radius, that is from this to this. Again, elaborating, first I have to draw a picture involving different variables. Okay, so first there is a water draining from a funnel, conical shaped funnel. The height of the funnel is 2 feet and the radius is 1 feet. Now as the water discharges from the end of the funnel, that the height of the water and the radius are changing over time. Now two basic parameters are the height and the radius both changes with respect to time. So we make these now we have different height and different radius. So I denote these quantities with variable h and variable r, this one and this one. So we have to find that at what rate is the height of the water changing when the height of the water is this. Okay, so I have to find the rate of the height of the water changing when there is a flow of height and the height of the water is half feet. Okay. So first step is to draw a pictorial diagram that represents the known and unknown values. Okay, let h, you have to specify that let h denotes the height of water and r denotes the radius at surface, and v is the volume inside or the volume of the water. So we we need to determine dH upon dt, as I described that the thing at what rate. Rate is the height that I have to find. Rate mean change of rate mean we have to find the change with respect to time, and the variable is height. So it will be dH upon dt. So dH upon dt. Now the height is half feet, and we know that the change here it is. There is one another thing that water is draining. Draining means that this point is the drainer, which basically decreases the height. So water is draining from the bottom of the cone at the rate. So from this point, from bottom, the draining rate is 0.03 feet cube per second. Okay, so this means that the volume dV upon dt, change of volume with respect to time, is 0.03 feet cube per second. So the next thing is, this is dV upon dt. So now when there is draining, there must be decrease in the volume. So the change in volume must be negative. Why? Again, with the draining, as when there is no drain, that there is a stopper, the height of the column or the volume inside is this. Okay, when there is no stopper and water is draining, so the height decreases. So height decreases means the volume decreases. So this means that the rate of volume decreases with decrease in height. So there must be that it will say that dV upon dt, that is change with respect to volume, is negative. Okay, so because it is decreasing, you have to say that it is decreasing. So this will be written as dV upon dt will be equals to negative of 0.03 feet cube per second. Okay, so this is the dV upon dt, that is change of volume with respect to time. So this is the second step, that what is the known and what is the unknown. So we have to find dH upon dt, that is change in the height or change in the rate with respect to height of the funnel. When h equals to, when height equals to half, okay, half feet. So now the next value is known, that dV upon dt is negative of 0.03 feet per second. So this is the unknown, and h and dV upon dt is the known value. Now how to find it? Now the next is governing equation, or the governing equation for this is the volume of water in the cone. So basically the volume, it is a conical surface, so it will be, volume will be 1/3 pi r square h. V equals to 1/3 pi r square h. From this figure, we see that we have similar triangles. Therefore, the ratio of side in two triangles is the same. Okay. Now the next thing is we have to go to the diagram. Let us say I have to draw here diagram. This is h. Sorry, this is 2, and this is 1. Radius is 1. Now the second, this is minus, so this is r. And this is h. Okay. From the figure, we see that we have similar triangles. Okay, so the triangle shapes are this is the first triangle. Okay, now the second triangle will be this one, this complete one, bigger triangle. So the ratio is same. Okay, so we have similar triangle. Therefore, the ratio of sides in two triangle is the same. That is the aspect ratio or the increasing ratio for both the triangle is same. So I have to compare both sides. So this will be ratio of radius upon height. That is this ratio of r divided by h will be equals to 1 divided by 2, that is the radius of bigger triangle, that is 1 divided by the height of greater triangle, that is 2. Okay, so this will be r equals to h upon 2. Again, from the figure, we make an assumption that these are the similar triangles because the ratio of sides in two triangles is the same, that they are increasing in same ratio. So the ratio of radius and height will be same. So taking this, radius divided by height of one triangle will be equals to radius divided by height of the second triangle. So first triangle, this one smaller r and h, which will be unknown, and second is 1 and 2, which is known. So putting the value from here, I can find the value of radius, that is radius equals to h upon 2. Okay. Now v equals to 1 upon 3 pi r square h, and this will be 1 upon 3 pi. Radius is what? Radius we find is h upon 2 square into value of h. So it will be 1 upon 3 pi h square divided by 4 multiplied by h. Now this h and square will be multiplied, so it will be h cube pi and 1 upon 12. So it is 1 upon 12 pi h cube. This is the value of v. Now I have to apply the chain rule to differentiate it. So again, I have to that v equals to 1 upon 12 pi h cube. I have to find the derivation. dv upon dt will be 1 upon 12 pi h cube will be 3h square. So it will be 3 pi divided by 12 h square. So by dividing both, so it will be into dh upon dt. We have to differentiate with respect to h. So it will be pi divided by 4 h square dh upon dt. This is the value of dv upon dt. Okay. Okay then. So we have to find these two values. We have to find these two values. That I have to find dh upon dt with height value is 1 upon 2 feet, and the rate of volume is minus 0.03 feet cube. So I will find that v equals to, so dv upon dt equals to pi upon 4. Okay, then is it h square dh upon dt. So it will be minus 0.03 equals to pi upon 4. H is 1 upon 2 square with dH upon dt. So it will be minus 0.03 pi upon 16 dH upon dt. It is negative of 0.03 multiplied by 16 divided by 3.14 equals to dH upon dt. So dH upon dt will be negative of 0.48 divided by 3.14. So it will be negative of 0.1533%. So this is the end of today's lecture.